So basically from our perspective, it is good to know a little bit of the early history. I've taken a couple of slides because very often when we talk about Aedes, it's sort of a lost case and everyone says that vector control really doesn't work. So it's always good to recollect that vector control did work. In the 70s, a good percentage of this continent of South America were free of Aedes. But then we let it go, and this is where the whole thing failed. And if you really look at what happened in those days, it was, of course, a very highly successful program, well-funded, with enough resources of trained personnel, equipment, and insecticides. They emphasized on both source reduction as well as on residual spraying targeting the adults. It was, of course, a vertical program, and it was, of course, had its great benefits. Now, most of the vector control programs, basically in the outbreak of Zika and chikungunya, what has happened mainly in the PAHO region is that they have used the dengue global strategy as well as the PAHO strategy, adapted it to the need to address Zika and chikungunya. And so it is always good to remember that there is a global strategy for vector control, basically on targeting dengue. And this addresses both diagnostics, case management, sustained vector control. There is avenues for vaccine implementation and research. One of the key elements of the Zika outbreak was we convened the Vector Control Advisory Group at short notice, and this group came up with a recommendation that most of the current tools which are used for control works provided they are implemented properly and monitored properly. So here we have the main 4 areas are, of course, targeted residual spraying works, space spray, especially indoor space spray, larval control, and personal protection measures. In addition, VCAG also recommended that pilot implementation of Wolbachia and Oxitec transgenic mosquitoes can be done with robust monitoring and evaluation. This map was already shown, really highlighting the distribution of Aedes, and frankly today we have Aedes presence, mainly either of the 2 species, in over 130 countries. And the success of this species, as most of you know, is because of several factors. One, it prefers to bite on humans. The 2 key elements which we all need to remember at the back of our mind is, one, Aedes eggs can withstand desiccation. And according to literature, it can go up to 400 days. It can remain dry. And the moment it comes in contact with water, it will hatch. The second key factor is, as was mentioned by the previous speaker, it is a multiple feeder. So this causes clusters, it causes widespread distribution of the same disease in a particular locality, and of course it is a day biter, as all of you know. We also know that there are more evidences coming that albopictus do play a role. There are suspicion of Aedes henselae, and Aedes polynesians is playing a role mainly in the Pacific. The challenge of vector control, essentially for arboviral diseases, is that there is definitely a lack of resources across the board. Most of the programs are still not adequately staffed. Very often, vector control is used as a last resort for an outbreak management. And what WHO is promoting is, as part of our global strategies, please shift from outbreak management to sustained vector control intervention. If you have succeeded in malaria control, it was not as an outbreak management, it was due to sustained 25 or 30 years of control effort. And as you know from the recent publication, vector control alone has contributed 70%, almost 78% to the success of malaria. So sustained control is a key. There's no point, as soon as an outbreak starts, they start to mobilize equipment. By the time the insecticide is procured, or you get your staff on the ground, the outbreak would have reached the peak. And very often at the end of it, vector control gets blamed. It is not working. Now, the other challenge we have is, of course, the decentralization of the program, which of course provides a golden opportunity to train staff at various levels, but at the same time it's challenging because we really do not have a central focus, and decentralization is an area where it is basically a dilemma, whether it is good or bad. If it is implemented properly, decentralization is good, provided you train all the staff adequately with good coordination. But if it is not, we would face a crisis where we would run short of staff. Urban vector control. This is the real elephant in the room here. We have not mastered the art of vector control in urban areas. We blame the Ministry of Health, but honestly, it is strictly not the Ministry of Health's responsibility in an urban environment. There are several ministries involved. We, of course, sideline dengue control just because we know it is a complex issue. But we cannot ignore it any longer. Really, it has come to a point where in the next 5 to 10 years, 80 or nearly 75% of the global population will be urban. And these are the diseases which are going to cause havoc. We had Zika, now we don't know what is next. There will be many more coming through the mosquitoes, because there are 500 RNA-based viruses with potential for transmission. So essentially, we are talking about a combined vector control. Unlike the other forms of vector control, we need a combined operation where you target as far as possible the larval stage as well as the adult stage. We have several tools for it, and we need to prevent the development of a human vector contact to the minimum and make sure that the population is kept under check. As you all know, this paper really summarizes the whole range of vector control tools available at our disposal. The top half, which is slightly lighter in shade, shows the tools which are available, and the bottom half really shows some of the tools which are currently in the pipeline, which includes Wolbachia, attractive toxic sugar baits, spatial repellents, the transgenic mosquitoes, sterile insect technique, and to add the last one is now the gene drive. So there are several tools coming through. Some of them have great potential. Some of them are in the phase 3 stage. So one of the challenges, as I said, is the eggs. And this really shows the challenge we face. These are laid in isolated. They may aggregate. And as you can see, that this picture actually is from Sudan. So that's why my colleagues from Sudan are having a good laugh, because this is one of the challenges. How do you remove eggs from these sort of containers? This is a huge challenge, because they are quite rough and you cannot really scrub them easily. Larval control, we know that it has to be done very strictly, regimented operation, very comprehensive with monitoring and evaluation. And again, the impact of this is not fully proven. And we know that current tools have not really been evaluated through a rigorous trial, especially for dengue control. And we are beginning to see more and more such publications coming through. We have one paper published on RCT. Several more are in the pipeline, and we hope that more rigorous trial and evidence of impact would be generated in the coming years. So basically, we really need to move from a reactive approach to more planned, preventive, sustained vector control operations. In terms of larval control, we have several tools, because we are talking in this meeting about resistance management. Actually, larval control, we have an array of tools to avoid the resistance. So you have organophosphates, insect growth regulators, we have biopesticides, all the tools which you can rotate around. But unfortunately for adulticide, we don't have that. We have only 2. Then, of course, you have these containers which can be covered, and there are trials which have proven to be very successful from an entomological point of view. And in some communities, especially in the Philippines, I have seen that communities go out to get this. They pay for it. And they are not covering it for mosquito control, but basically to make sure that the container is well covered from dust and all dirt. And this is quite good, because if you can promote it aggressively with subsidized marketing, I think this has got a great future in communities which accept it. Now, space spraying has been a lot of controversy, but expert opinion as well as current publications point to the fact that indoor space spraying do work. How well outdoor space spraying work, that is still being debated, but indoor space spraying has an impact and we have publications on it. Our challenge, of course, is do we have sufficiently trained manpower to carry out all these vector control operations? And the answer, to a great degree, I'm sure all of you would agree, except for a couple of countries, there is a great dearth of trained workforce to carry out the vector control operation at the right time, in the right way, at the right dosages. So the challenges, of course, we know we have pyrethroid resistance, we have organophosphate resistance, and then the disease as such, though we focus on urban vector control, it is moving to semi-urban and rural areas. More and more, especially chikungunya, is affecting rural populations in Asia. So this is a challenge. We are also looking at how to strengthen points of entry. We have worked closely with the international health regulations to develop guidance document on surveillance and control of vectors at points of entry. Climate change, again, the evidences are weak at the moment for arboviruses, but here again, our evidences are not really direct. It is very closely linked to water storage practices. So if you hoard water, and because of erratic water supply, there is definitely a potential for promoting Aedes breeding. And we have several examples of this, most of which are in the gray literature. And of course, we know that, as I said, epidemiological endpoint is very important. And this was the first paper in BMJ which really showed that community-based vector control had an impact in Mexico and Nicaragua in dengue transmission. As I said, there are new tools. We have the riddle technology, which is now being, I know it is being scaled up in Brazil and a couple of other countries in South America. And there is a lot more effort, and they are also focusing on RCT trials. Then we have the Wolbachia, where we have two different approaches, both population replacement as well as population suppression. And you will hear more about the population suppression from Singapore, because it is one example where we hope we will have very good positive answers in the next couple of years. So essentially, we are talking about sustained vector control with sound vector surveillance linked closely with clinical and lab surveillance. Resources and personal management is a very crucial element. We need to make sure that our resources are properly planned and utilized. Integrated vector management approach can be used, which involves source reduction, combination of vector control. Perifocal spraying is again back on the horizon because there are several trials going on it, and there are many publications from Australia. The treated curtains, treated materials are also possible avenues which can be sustained and has potential. And of course, as I said, monitoring and evaluation is the key. Unlike malaria, in dengue, we will have to monitor for 3 to 5 years because of the spatial distribution of the disease. And this is the challenge. It costs more money and more resources to generate the hard data and evidence. As a part of the Zika outbreak, we developed four different guidelines, one of which is on surveillance. The second was on monitoring insecticide resistance for Aedes mosquitoes. The third was vector control operation framework for Zika. And the fourth was on personal protection, which was developed by a different unit in our department, which are really now specializing to make sure that we are adequately protected. In terms of preparedness, actually, WHO has several approaches, one of which is to have regional stockpile. And one stockpile is actually in the Pacific. We have a stockpile of equipments and insecticides, rapid tests, mainly based in Fiji. We also have initiated several efforts to develop regional capacity so that staff can be deployed quickly as and when needed. There is, of course, the focus will be on national capacity building and national preparedness and early warning systems. And WHO also has a network of laboratories, experts, and training courses, essentially to develop capacity at various levels. So these are the various approaches we are taking in terms of preparedness. And for example, right now in Burkina Faso, we have an outbreak of dengue. We have mobilized local staff, especially drawn from Institute Pasteur and other centers who have been deployed along with CDC colleagues who are working along with us in Burkina Faso to contain it. Now, if you really look at Aedes as a problem, it falls as an excellent candidate under SDGs to link up several SDGs. We have 17 SDGs, but health is only SDG 3. But apart from health, Aedes is closely linked with SDG 1, linked to poverty. It is linked to water supply and sanitation. It is linked to sustainable cities, climate action, and of course, partnership. So actually, we can position Aedes control as one of the pillars for an integrated SDG effort. So it is accepted, UN has accepted that each goal is important in itself, but they are all connected, and we need to work towards it. The other thing we are developing, as I said in the introductory part, is the WHO's Global Vector Control Response, which will go to our executive board in 2017. And this paper was actually on the web till 3 days ago for open consultation, and I know many of you had contributed and commented on it. We are very grateful to that, and this document is now entering its fourth version and will be ready for the January meeting. So this is a document which really prioritizes vector control as a key, not for malaria alone, but across all vector-borne diseases. So in conclusion, basically, Aedes-borne diseases in the 21st century, we have got an uncertain distribution and burden. 2 vectors are transmitting more than 4 diseases. As malaria is declining in many parts of the world, dengue, chikungunya, Zika, West Nile are increasing, and Africa is a basket where we know very little about it. So we have a lot of work to do there. The impact of environmental change, we need to still continue to monitor. The vectors have silently expanded with cryptic breeding sites, and current tools needs good sound evidences along with the newer ones which are coming, and efforts must target all stages of the mosquito. Before I conclude, I also wish to announce that we are convening a meeting on Zika vector control, mainly to learn from experience of countries who have done vector control for Zika and to document them. And actually, as we speak now, we have about 4 clear evidence of vector control having an impact, one of which is from the CDC effort in the American region, second is in Singapore, third in Cuba, and there's some more coming through in the pipeline. So essentially, we can bring all these lessons learned, including probably the lesson in Rio after the Olympics. We would have a sound evidence base to justify vector control interventions for managing arbovirus. So we are convening a meeting of experts, and any one of you, if you are interested, please contact me. Thank you.